All right, so the next thing that we're going to talk about here is something called template literal types. But before we get into template literal types, what we're going to need to take a look at first is something called string literal types. So what I'm going to do here is I'm just going to create a new file, and we'll just call this literal types.ts. And first of all, a literal type in TypeScript is when, instead of setting the type of a variable to a class of different values, right, such as if we say let x number equals 10, right, this means that the variable x can hold any number we want it to, right, not just 10. Right, so later on if we wanted to say x equals 20, that would be perfectly fine. And then maybe later on we could say x is equal to -5. You get the idea. So this is how regular primitive types in TypeScript work. However, there is something called a literal type, where basically you can say that instead of a variable being able to hold any number or any string or any whatever, we constrain that variable to holding only one value. Now, this might not make a whole lot of sense why you'd want to do this at first, but bear with me here, we'll get to that. So let's say that instead of x being a number, we want it to be a string, but we only want it to be able to be a very specific string, right? Namely, we only want it to be the string hello. Well, in that case, what we could do, you'll see that if you hover over the variable name x, that TypeScript automatically infers that this is a string. However, what we can actually do is put a colon after x, and instead of saying string, we can say hello, right? Now, if we hover over x now, what we'll see is that hello is actually the type for x. Now, again, this might seem a little bit confusing, but in this case, we can't set the value of x to anything else, right? X can only ever be the string hello. So if we try and say x equals goodbye, right, like so, then we'll see that TypeScript doesn't like that because it says type goodbye is not assignable to type hello. Well, really the main benefit of these literal types is to help us create sort of enumerated types in TypeScript where a variable can only hold one of several different values. So to show you what I mean by that, let's say that instead of x just being able to be the string hello, we want x to be able to be hello or goodbye or hi, okay? Well, in this case, we can assign hello to x because that's one of the literal types that we've put after it, but we can also change its value to one of these other literal types that we've given it. So we can say x equals goodbye, and TypeScript's perfectly fine with that, right? However, if we try and assign a value that isn't one of these literal types that we've unioned together using the union operator here, right? If we try and say x equals hey, well, that's not going to work, right? Because TypeScript says type hey is not assignable to type hello, goodbye, hi. All right, so now that we know more or less what these literal types might be used for, let's see a slightly more useful example of this. A slightly more useful example is when we want to limit what the user can set a variable's value to, or limit the type of an argument that a user can pass in, right? So let's say that we want to use TypeScript to create some sort of game that takes place on a grid, such as tic-tac-toe or Battleship. Well, in that case, there's going to be a limited number of options that the user can submit for their move, right? So first of all, in games that take place on a grid such as Battleship, the columns are usually numbers. In Battleship, I believe it's like 1 through 10, and the rows are labeled with letters, right? I think that's capital A through capital J, right? So if we wanted to limit our TypeScript types to those values, what we could do is we could say something like type, and we'll call this column label. And then instead of saying that this could just be any string, what we can do is we can actually define the different values that this could be. So we could say 1 or 2 or 3 and so on, right? And type-wise, that's going to limit variables of type column label to those values. And we'll just do 1 through 3 for now, just to keep it simple. And likewise, if we wanted to say type row label, we could say equals, and instead of allowing the user to enter in any string for that, we could limit the user to passing in A, B, or C. All right. And one thing that I just want to point out here is, even though I've been saying things like if we want to limit the user to entering in 1, 2, or 3, or entering in A, B, and C, I want you to understand that the types here aren't actually going to limit the user to doing anything, right? In other words, if we get the user input and put it into a variable with type column label or row label, well, at that point, right, at runtime, the types are no longer going to be there, because remember that the types only help at compile time, right? They help us catch logical inconsistencies in our code, right? So in other words, if we just had a random string that we got from the user, right, such as user input, and maybe the user entered in the column that they want to attack in Battleship, well, the user could really type in anything they want, right? And TypeScript isn't going to prevent them from doing that, right? At that point, again, TypeScript isn't going to be around any longer. However, what this will help us catch, right, if we create some sort of function called something like attack square for Battleship, right, and this allows us to specify a column and a row that we want to attack, right? So we would start off by saying row label, and column label. Well, now if we try and call this attack square function with something that the user has entered, right? So let's say that we get a row from the user. So we'll say user row input, and we'll say user column input. Maybe the user enters in something else too that doesn't fit in with our labels. Now what would happen is if we try and call attack square with these user row input and user column input things without making sure that these variables fit these custom types that we've defined, TypeScript isn't going to allow us to do it, right? It's going to say you're trying to pass an argument of type string when the type should really be row label, right? Well, in order to make this work, what we would have to do is we would have to define a function called something like isRowLabel, okay? And what this would do is it would take a string, so we'll just have some random string here, and it's going to return whether or not that string that we pass as an argument is a valid row label. So what that would look like is we could just say return, and then we could just return whether the valid row labels, such as A, B, and C, include that string, right? So in this case, that would return whether or not one of these strings is a valid row label, and then we could use an if statement to check that, right? So we could say if is row label, and we'll pass in user row input. Well, in that case, we could call attack square, and that should make TypeScript happy. There's actually one other thing that we need to do in order to make TypeScript happy, because if we hover over user row input here, we can see that TypeScript hasn't yet been able to infer that this isRowLabel function actually qualifies this user row input as a row label. So in our case here, what we need to do is add a qualifier after this isRowLabel function that looks like this. We can say is, we can say colon, and then string is row label. All right, now that looks a little bit funny, but basically what that tells TypeScript is that if this returns true, then this string should be considered to be a row label. And you can actually see that the error here has disappeared from user row input. And if you hover over user row input here, you can see that TypeScript has inferred that this is a row label because it's inside an if statement blocked by this isRowLabel function. And we can do the same thing with the column label type as well. If we say function is column label, well, what that looks like is we can just say string, string, and then we're going to say string is column label. And then we just need to do the same thing that we did up here. We're just going to return whether this string is either 1, 2, or 3. And now we can use that to block this if statement as well. So we can just say and is column label user column input. And as you can see, that makes all of the type errors go away here. So anyway, that's how string literal types work. So let's talk now about template literals. Basically, template literals allow us to take string literals that we've defined, such as these ones here, and combine them to get all the possible combinations. So in our case here, with our Battleship game or tic-tac-toe game or whatever you want to create with a grid that has both column labels and row labels, what that would look like is we might want to create another type called something like Battleship move, or game move, or whatever you want to call it. And we might want this to be all the possible combinations of column label and row label, right? So A1 would be a valid move, B2 would be a valid move, C1 would be a valid move, but something like D5 wouldn't be a valid move. And in order to specify this in TypeScript, all we have to do is say type battleship move, and then we're going to use backticks here. And just like we would normally insert the value of a variable into a template string in regular old TypeScript or JavaScript, we're going to say row label, and then next to it we'll say column label. So what we're doing here is we're saying that a battleship move basically just consists of any of the valid types for a row label next to any of the valid values for a column label. So, all right, so now if we try and say something like let new move and assign the battleship move type to that, and then try and say something like A1, well, TypeScript's perfectly happy with that, right? And you can actually hover over this battleship move thing to see that TypeScript has indeed gone and generated all of those possibilities for us. However, if we try and enter in something like D1, well, that's not going to work, right? TypeScript says type D1 is not assignable to type blah, 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 right? A1 through C3, essentially. So that's how template literal types work. They basically allow us to take simpler literal types and combine them to create a new type. So now if we wanted to re-implement this logic with a user entering their move just as a simple string, right? So let's say that the user enters the string A1. Well, in this case, we might want attack square to take a battleship move type instead of column label and row label, right? So we could just say move, and we could say battleship move for the type. And then for our functions, we could create another function called isBattleship move. And this would take a string as an argument, and it would basically qualify that string as a battleship move if it returns true. And in order to do this, all we would have to do is split this string into its component pieces by saying let row and column, and then we'll say equals string.split, and we're just going to pass an empty string there. So this will split the string into its characters. And now that we have the row and column, which as you can see is both of these variables have the type of string because string.split returns an array of strings. What we can do now is we can just say return is row label row and is column label column. Okay, and that will qualify a move as a valid battleship move. So now we can just say if is battleship move and pass the new move that the user entered up here as an argument. And then that would allow us to pass this new move as an argument, right? And it's worth noting here that if the user didn't specify a valid move, right, if they were to enter in something like hello, that's not a valid battleship move, well, even if this happens at runtime when TypeScript isn't going to be checking it, note that we still have this if statement that's going to prevent this attack square function from being called with an argument that won't work. So anyway, that's how literal types and template literal types work in TypeScript. The last thing that we're going to take a look at in this section is the key of and type of operators. So that's what we'll be taking a look at next.